Welcome back, Leo Lions. This is Mrs. Morgan with the second lesson over area of circles. So we have discussed everything on this page, the parts to the circle, the radius, the diameter. We talked about circumference and those formulas. Well, now we are going to focus on the area formula, pi r squared. So on the back side, we have area examples. So in this formula, we have to be careful. It's a little different where circumference, we had 2 pi r or pi d. We had a formula with each of those variables. Notice the area formula, we only have the radius. We cannot plug in the diameter. So we really have to be careful with the formula. So in this scenario, we always ask ourselves, what are we given? We have from the center to the outside of the circle, so this is our radius. So when we're given the radius, then we can just plug that into the formula. So area is pi times, we have 9 squared. Now, if you remember from the first video, circumference, we talked about how r squared is totally different than r times 2. Think about 9. If we multiply 9 by 2, 9 times 2 is 18. But squared means 9 times 9. So I'm going to write off here to the side 9 times 9 to help you remember. And that's 81. That's totally different than 9 times 2. So again, we're going to do exact answers and rounded answers. 9 squared, 9 times 9 is 81. So 81 pi is our exact area. Now with area, we have our label meters, but area is squared. So we have little tiny squares, or in this case meters, that fit inside this shaded region. So we have to think about meter squares and how many are fitting inside that shaded region. That's what we're really finding when we are looking at area. So that's why we label our unit squared. Now from here we will go back to Desmos and we will do 81 times pi. Now you could also do what I said with circumference. You can do pi times, and then we have 9 over here. We have a squared, that button, and it will square it. You can do it all at once, and notice those two answers are the exact same. So it'd be 254.46. Oh goodness, it took me out. Let's go back to those notes. I apologize. And there we go. So 254. And then remember, we want to round to the nearest tenth. So it was 0.46. So if we round to that nearest tenth, we're looking at the number next to it. The 6 tells us we need to round up. So the rounded answer would be 254.5 meters squared. So again, kind of two answers here. Always read your instructions to figure out, do we want an exact area, or it will say use pi in your answer, or it will tell you to round. So there are two area answers. All right, I'm going to jump down again to the one below it. So figure out, what are we given? This scenario, we have the distance all the way across the circle. So we know that this is the diameter. Now, remember I said we cannot just plug the diameter 4 into this formula because it is pi r squared. We have to have the radius. So if the diameter is 4, well then we know the radius is the center to the outside. We know it's half of that. So 4 divided by 2, we're going to cut it in half. We know the radius is 2 centimeters. So if you're given the diameter, the first step, we have to find the radius. Now we can plug it into our formula. So area is pi times 2 squared. And it would be a totally different answer if you accidentally put the diameter in. It would be wrong. All right, 2 squared, 2 times 2, so that is 4. So our exact area is 4 pi, and this label was centimeters squared. So that's our exact. Then we can actually go over and do 4 times pi, and we get 12.56. So again, kind of like that last one, we want to round 12.56, round to the nearest tenth. So the number next to it, the 6, tells us we need to round up. So the rounded area would be 12.6 centimeters squared. So again, we have two answers. They're the exact same answer, just one has the pi in the answer, one is rounded and multiplied by pi. Again, pause here and see then if you can find the area of the two circles on the right side. And then press play, see if you're on the right track. So this next one, we have from the center to the outside, so we have the radius is 58. So we'll plug 58 into our formula, pi r squared. So pi times 58 squared. Now, I do not know 58 squared off the top of my head, so I'm going to come over here. You can type in 58 times 58, but you can also hit this squared button and it does the same thing. So 3,364. So 3,364 pi, because I haven't multiplied it by pi yet, and this is labeled centimeters. So centimeters squared, that is our exact answer in terms of pi. Now I am going to take the 3,364 and I can actually just type it in here. Times pi, oh wow, 10,568, and we would round that 2.3. So 10,568 0.3 centimeters squared. That is our rounded area. So there are our two answers again. All right, one more. We have our diameter in this scenario all the way across. So the diameter is 23, but for our area formula, we need the radius. So we're going to take 23 and remember, cut it in half to find the radius from the center to the outside. So 23 divided by 2 should be 11.5. And if you didn't know that one off the top of your head, you can always come over to your calculator. 23 divided by 2. Notice that whatever I'm putting in my calculator, I am showing in my work in our notes here. So make sure you are always showing what you put into your calculator to be able to prove how you're getting your answer. So we're actually going to put in a decimal for our radius. So pi times the radius is 11.5, and then we square it. So I'm going to go back to my calculator and do 11.5 squared. That is 132.25. So 132.25, and you could round up to 0.3. Since it terminates, it ends, I'm going to actually write out the full number there. And then we have millimeters squared. That is our exact area. And then last step, we will actually multiply it by the pi button. So I'm going to keep that in there and just do times pi. So 415.47. So round to the nearest tenth. So the 7 tells us we will round up to 0.5. So the approximate, the rounded answer for our area, 415.5 millimeters squared. Okay, so that is how we find area and circumference. Those formulas will be given to you as 7th graders. As 8th graders, you would not get the circumference and area formula, and you'd have to memorize those. So hopefully we'll get enough work using those formulas. Notice every single question, all 4 of these, I wrote down the area formula first. And then directly below it, I wrote down what I plugged in for the radius. So the more you write it down, the better you'll get using it, and the better you'll remember that formula in the long run. We're going to do one of these mixed examples that says find the area and the perimeter. So area, notice over here, it's an odd shape. It's not a perfect circle, it's an oval. So we have 2 shapes here, and I'm going to do them in different colors. So we have a rectangle, and then we also have basically half a circle here, and half a circle on the other side. So if we took out that rectangle in the middle, well, those two semicircles would combine into one giant circle. So to find the area, we need to find the area of the circle that I did in red. And then we also have to find the area of the rectangle. And then we just add those areas together to get the total area. So area of the circle, we know it's pi r squared. We've been working on that. So all the way across, we are given this 13 centimeters. That means it's going through the center all the way across. So we know that the diameter is 13 centimeters. But our area formula has the radius. So we've got to divide that by 2. So 13... I'm going to make this a little easier to read. 13 divided by 2, we get the radius is 6.5. Again, if you weren't sure, you could always come over to the calculator. 13 divided by 2 is 6.5. So when we do our area of a circle here, we want pi r squared. We're going to plug in pi times 6.5 squared. Now I'm going to do it all at once because we're going to round in the end. So in my calculator, I can do pi times 6.5 squared all at once. We get 132.7. All right, that is the area we just found of this side and this side over here. So all we have left then is this rectangle in the middle. So the rectangle, remember the area formula for a rectangle is just simply length times width. So the length of the rectangle is that 13 centimeters. And I kind of colored all over it. So 13 centimeters is the length. The width, it tells us right here, is 6. So 13 times 6 will give us the area of the rectangle. So 13 times 6, we get 78. And then last step, we need to add those together. So the total area of that shape, we're going to do 132.7 plus 78. Notice I lined up the decimal since 78 didn't have a decimal. And you can use your calculator. So we'll do 78 plus 132.7. We get 210.7. And make sure you label correctly. This is area, so this is centimeters squared. And that is our rounded answer. All right, then last step, it does say find the perimeter. So we would actually need to find the circumference of the circle. So that would be here and here. And then we have 6 and 6. So perimeter, remember, is everything on the outside. So we would want to find the circumference. Remember, we can use 2 pi r, or we can use pi d. We already wrote down over here the diameter and the radius, so I'm just going to stick with pi times diameter. It's a little less work. So pi times the diameter was 13. Again, I'm going to approximate this, round it. So 13 times pi, we get 40.8. Now, what happened here is we just found this half circle, this semicircle at the top, and this semicircle at the bottom. We found the full circumference of that circle. So all we have left is this side and this side, those sides in the middle. So we know one is 6, the other side is also 6. So we just have to add that circumference, add 6. Again, I'm lining up my decimal. Add another 6 for the other side. So we get 52.8. we're talking about a perimeter, just a measurement, so we just label it as centimeters. So there is the perimeter of the circle, and then on the other side we found the area of the circle. All right, now if we have time, we're going to talk about the other two examples in class, but for the sake of time right now, we're just going to stop there.